Are water-based paint much safer compared to solvent-based one? Let us cover the answer from the perspective of ventilation engineering. Now, if we were to look at the evolution of the paint industry, right, back in the 20th century, the pigments in paint were in the form of arsenic. Now, of course, it was fulfilling its work as in the application of paint, but again, arsenic, as we know, is a very imminent chemical, imminent hazard, when it comes to its application. Then, somewhere before Second World War, pre-Second World War, the turpentine replaced arsenic. Okay, when we know that arsenic was way too dangerous in its application. Then, right after World War, with the enhancement in globalization and enhancement in industrial development, right? The demand of painting industry became very important. As we know now, paint is a form of coating. It's a form of coating. It's a form of surface protection, which is required in vast areas of industry, vast areas of application whatsoever. So this demand gave birth to this demand basically made way to advancement in usage of chemicals like methyl ethyl ketone, white spirit, butano, ethyl acetate, butyl acetate. In fact, now we know that BTEX, benzene, toluene, ethylbenzene, and xylene are the most important element when it comes to solvent-based chemicals. But regardless of its vast application, one can never deny the impact this chemical has if it is exposed or introduced into the breathing zone of the worker. So while we are balancing between the usage, the application, and the safety aspect, but we have another form of chemical which is what we call water-based paint. Now, the impact this chemical has if it is exposed or introduced into the breathing zone of the worker. So while we are balancing between the usage, the application, and since the formation or since the usage of water-based paint to substitute wherever it's possible, in solvent-based. The biggest question is solvent-based paint completely safe? Okay, from the manufacturing perspective or from its application perspective, is it completely safe? Now, water-based paint contains, if you were to look at the elements, all right, what we are doing is we're trying to use a much safer element. Now, a typical paint would have organic solvent. A typical paint would have biocides, surfactants, pigment, binders, amines, and monomers. All right. What we're doing here is we are basically just substituting VOC. All right. Okay. But that doesn't mean it doesn't have any chemical at all. Element in this paint would still get evaporated, will still get airborne, and it can still be introduced into the breathing zone of a worker. You see, as we know, chemical enters the body via inhalation, via skin absorption, injection, and ingestion. And among all this, the most significant pathway would be respiratory system, inhalation, because the surface exchange we have in our lungs, which is about 300 to 1,000 square feet, is way too big compared to skin absorption, which usually covers about 20 square feet of surface exchange. So taking that into mind, now let's look at the ventilation, involvement of ventilation to control this. Now, from now we know, regardless of having less significant impact, but the hazard is still imminent. So since the hazard is still imminent, what we want to do is we want to remove this contaminant in a paint industry, in a water-based industry, manufacturing, we still want to remove that less significant chemical away from the breathing of the worker, because when it is being exposed, when it enters the body, you're still going to have the occupation. I mean, you're still going to have it is still a risk, and there is still going to be impact if it goes above the occupational exposure limit, or the threshold limit values. So, what we need to do, first of all, we need to quantify. We need to understand how exactly the process is going to be. If it is going to be a blending, now we need to know how much emission is going to be generated. Then choose the best application. Now, depending on what sort of process it is. Depending on what sort of process it is, we must choose the application. Okay. Now, what we're going to do here is, if it is a blending, now during blending, or if it is during prior to blending, when you're gonna charge, or when you're gonna load this chemical into the blending tank, there has to be, if it is in particulate aerosol, if it's powder form, there has to be hopper. If it is not, you should have some kind of enclosure, and there has to be a suction at the air displacement point of a blending tank, so that whatever vapor is being displaced, the moment we enter it into a blending tank, you see displacement of air will take place compared to the solution. So we need to put a local exhaust ventilation at the mouth, or at the opening of the tank. You see, now if it is going to be for packing, now there has to be extraction arm being placed very close where the packing taking place, or some kind of customized hood itself can be applied depending on what sort of dispensing methodology is being applied upon blending. You see, so this has to be formulated, or this has to be designed by a design team and also the manufacturing team to ensure that the vapor, the elements of airborne elements can be completely removed at the point of generation. Now, next question: do you need now, as we know, ventilation system has 5 components, right? We have the hood, we have the ducting, we have the air cleaning device, the fan, and the chimney. Now, the next question: do I need to use air cleaning device? Do I need to use a type of filter, a scrubber, or a dust collector? So this is very much depending on the amount of chemical being generated. Okay, if you were to take the concept of ACGIH and ASHRAE, if the generation of the chemicals are low, then you do not need to have an air cleaning device. So you can quantify this. Prior to designing a ventilation system, you could do air emission monitoring at the local point where the process is taking place. Okay, but apart from that, there is another factor need to be considered. It's very much depending on the local regulation or local department too. In this case, it's very much depending on Department of Department of Environment. Department of Environment. If the Department of Environment puts a gazette, puts a rule of thumb that you must install an air cleaning device, regardless of the concentration at the emission point or in the point source, then you have to install. Lately, Jabatan Alam Sekitar is Department of Environment in Malaysia is going all out to get system installers or system owners to install air cleaning device regardless of the concentration. Okay, this is because now in the past ventilation system can be installed without air cleaning device if the quantification or the concentration is small. But again, sometimes what happens is process change take place. When the process change take place, when the quantification becomes higher, when there is no filter, what happens is, now you see the purpose. Now, as we said, a ventilation system has 5 components. Hood extracts the airborne at the local point generation to save the worker. Now, ducting basically transport this contaminant along and delivers it to the fan. Okay, the fan would basically transfer this into a chimney. So what does a chimney do? A chimney would basically form a vertical discharge with a good momentum, 8 meters per second, 12 meters per second. And this momentum, what will do, it will create plume rise, elevation of the discharge at the at the sky level. I mean, it will not going to come down. So this elevation will create a dispersion of air. This dispersion would maintain its trajectory, okay, maintain its trajectory along, I mean, at the elevated level of the sky. That means it will not get downwashed and come into the ground level and affecting what do you call adjacent recipients, houses or domestic or anything which is nearby the stationary source, which is the chimney. Now we need to install an air cleaning device when the concentration is high. But what DOE, Jabatan Alam Sekitar, is saying is you install it regardless of having low concentration, because if you were to do a process change without considering upgrading the system, or if there was an accident, spill or whatever, you have the air cleaning device to ensure that significant amount of contaminant doesn't get into the ground level. You see, yes, plume rise, elevation, as I said earlier, elevation of the plume rise or dispersion can be used as a form of control, but very much depending on the concentration we are capturing. This is why in clean air regulation also we have the permissible emission limit. You see, we cannot emit anything above certain concentration, because if it goes above the concentration, the air dispersion via chimney alone is not sufficient. Okay, so I think we can wrap it up. We can wrap it up now. I think what we can understand is, okay, water-based paint industry, water-based paint application is definitely less hazardous compared to a solvent-based, which has way too many toxic chemicals, which is extremely volatile. You see, benzene, toluene, benzene, toluene, ethyl benzene, xylene, MEK, Solveso, white, Solveso, and so on. We can move on. But regardless of eliminating, substituting it, there are chemicals involved there are elements of chemical in the water. And if you're going to introduce ventilation system, local exhaust ventilation system, or general ventilation system, then we have to do a proper designing methodology, quantify the amount being generated, and objective must be to reduce the quantification, the concentration at the local point of generation. All right, and air cleaning device, the usage of air cleaning device must be based on the amount of concentration being generated at the local point. You see, and do you need to use the air cleaning device in Malaysia? Yes, at this present moment, Department of Environment, Jabatan Alam Sekitar is basically going all out to use air cleaning device as a part of the local exhaust ventilation system, mandatorily, regardless of the concentration at the local point. All right. So if you have further questions, do not hesitate to contact us at E8. We are obliged to help you, to assist you, to safeguard your workers from any form of airborne contaminant. Thank you. Good day. Bye-bye.